Okay, so hi, I'm Ranit Aharonov from the HR Lab, and I will talk about the AI, Project Debater, and give a very brief interview of what Project Debater is, and then Yoav, who's the architect of the project, will talk about the system behind. So you'll get both of those. So IBM Research has a very nice tradition of grand challenges. I think you're all aware that a little more than 20 years ago, Deep Blue was developed and it defeated Garry Kasparov in chess. And then in 2011, Watson computer defeated the two greatest players of all time in the Watson Jeopardy show. And right after that grand challenge, there was the question, what can IBM do next? What is the next grand challenge? And Noam Slonim from this lab here in Haifa had the idea of developing a computer that would actually have a full live debate with a human being on a topic, on any topic, hold a debate. And for more than 6 years, starting with a small group of people, growing to a larger group, a lot of infrastructure work, as Dalit mentioned, to fuel the AI. In 2019, we had a debate. This was in February in San Francisco. I'll show you a very small glimpse of that debate in a moment. The system got a topic. We brought sort of the Kasparov of the debate world. This is Harish Natarajan. He's a legendary debater. He has the most debate victories in history. And he debated the system. And this was got a lot of attention, a lot of media impressions, and so on. And also a lot of downloads of our data sets. I don't have time to go into that, but we are very active also in the academic community. There's a whole academic field called computational argumentation, like computational biology, that asks how can we use computational tools in this area of argumentation, persuasiveness, and so on. So a little bit about the debate that was our grand challenge moment, so to speak. So the topic of the debate was whether we should subsidize preschools. This topic was really a held up topic. The system did not train on the topic. It trained on a lot of other topics, but if you go to study in a debate class, obviously you want to learn how to debate and not how to debate a list of specific topics. So this is what we did with Project Debater. So it was selected from a test set, but I should say it was based on our assessment that this would be a good debate. You obviously cannot know how the debate unfolds because this is a debate, but it cannot debate any topic you give it, also because it mines data that it has in its memory. The format of the debate is that each side has 4 minutes for opening. So in the debate that went on, Project Debater is what's called the government. So the government is proposing to subsidize preschools, and then Harish was the opposition, so he's opening for 4 minutes. Then each side has 4 minutes for rebuttal, and then 2 minutes for summary. From the minute that Project Debater gets this motion, so the only input to the system at that stage is this very short text, we should subsidize preschools, everything is fully automatic. So I'm going to show you a short thing. So this you can calculate is about 20 minutes. Take also all the moderation in between and so on. It's a long thing. I'm going to show you 3 minutes or even less than 3 minutes of this.
Greetings, Harish. I have heard you hold the world record in debate competition wins against humans, but I suspect you've never debated a machine. Welcome to the future. When we subsidize preschools and the like, we are making good use of government money because they carry benefits for society as a whole. For decades, research has demonstrated that high-quality preschool is one of the best investments of public dollars, resulting in children who fare better on tests and have more successful lives than those without the same access. Secondly, a few words about poverty. While I cannot experience poverty directly and have no complaints concerning my own standards of living, I still have the following to share. Regarding poverty, research clearly shows that a good preschool can help kids overcome the disadvantages often associated with poverty. The OECD has recommended that government subsidize pre-primary education to boost performance in poor areas.
Well, thank you very much, everybody. It's a pleasure to be here for this historic event. And it certainly was a pleasure to listen to Project Debater. There was a lot of information in that speech and lots of facts and lots of figures. The problem, though, is the reality of subsidizing preschools is one which does not deal with the underlying problems in society. If you massively increase the number of people going to preschool, they're all going to be the ones going to the high-quality preschools. In a competitive environment at the age of 3 or 4, when you're learning that that other child is potentially better than you, when you realize you aren't necessarily as talented as someone else, that huge psychological damage for many children may mean that preschool is actively harmful.
Among other things, I think Mr. Natarajan suggested that preschools should not be subsidized because this will reduce their quality. I would like to offer a different view. I disagree with my opponent. Subsidizing preschools will have no negative effect on their quality. If anything, the opposite is true. One of many reasons is that subsidizing attracts more skilled and qualified people to the field, improving the quality of preschools for all. My opponent claimed that preschools are harmful. I believe my argument suggested that the benefits outweigh the potential disadvantages. I touched upon 3 issues: children, students, and crime. Specifically, I noted that preschool education improves children's development. In addition, I suggested that attending preschool helps students succeed. And a final point to consider is that preschool can prevent future crime. We should subsidize preschools. Thanks for your attention.
Okay, so this was a glimpse, and this is on YouTube. You can see the full debate anytime. It's very interesting, and Harish is really a pleasure to look at as well. So before I give Yoav the chance to really dive deep into the system, at a high level, it's important to understand what are the 3 main AI capabilities that fuel Project Debater. So one is data-driven speech writing and delivery. Project Debater in its memory has a corpus of newspaper and journal articles. It's about 400 billion sentences, and all of the information that Project Debater takes is from this corpus. It finds arguments, so there's the whole area of being able to take a massive text corpus and find relevant arguments on a topic, understand it in pro or con, and deliver a speech. Then there's listening comprehension, which is aggravated by the fact that you might have noticed that Harish started by saying does not mean and then corrected this means. So it's spoken language is very difficult to understand. And yet, in order to be able to suggest a rebuttal, the project debater has to understand the gist of what the opponent is saying. And the third component has to do with injecting knowledge into the system. There's a lot of knowledge about the world of dilemma and of debate. You can talk about very general arguments that can be pre-written, but you have to know when to say them and when to respond with those arguments. So this is at a high level. And finally, just a word about why this grand challenge is different. So I think you all know that AI has been going hand in hand with grand challenges from the days of checkers in the 50s through backgammon, chess, AlphaGo, and so on. But really, in all of those cases, you could determine who wins very easily. And this has massive implications for developing AI because you have a cost function which you can optimize, and you can have the system play against itself and improve by that. In debate, we are moving into the subjective world of humans. When a debate ends, there's no clear winner. There are judges and so on. So you cannot use all of these things to develop AI. And indeed, still in debate, humans prevail. This is not the area where computers are clearly already better than humans, which is the case in games. But looking at the bright side, this is where I think we can ask a lot of interesting questions in AI. So I'll give Yoav the chance to tell you about what's going on behind Project Debater.
Okay, so I'm going to talk about how the project started from its concept to the live debate that you saw, and I want to try to highlight some recurring themes that might be applicable to other AI and system projects. So what you saw, the project has many facets like speaking and listening. When the project started, the proof of concept was really to show that we can mine arguments from a corpus. That is, given the topic, identify claims and evidence within that corpus of data that will support our position. And this was done primarily in a supervised machine learning approach where we had partitioned the task into 3 parts. First is, given the topic and the corpus, identify relevant articles. given relevant articles, identify sentences and that contains claims and evidence for the topic, and finally, identify the polarity, whether these claims and evidence support our position or contest it. It was built as a monolithic Java application where there was a lot of shared code between these separate worked items, the basic NLP stack, tokenization, parsing, sentence splitting, annotation of the labeled data, which is critical for supervised learning, of course the machine learning algorithms and the reporting infrastructure. So initially you can see the data sizes. Wikipedia was about 40 gigabyte, all fit in a laptop. It took about an hour or two to run the training. It was also reasonably feasible. But as more data, training data increased training time, this became less convenient. But the real issue was this. You really have to check an integrated pipeline, not each component separately, because the output of one component is the input of the second component. In order to assess the value of the quality of each component, you have to at least often run the full pipeline. And this means that a great increase in computational time, and also because any component failure within that pipeline will cause the pipeline to fail, you are very amenable to problems. So this was at the point where the architecture team was formed, and we started to build infrastructure to run this entire pipeline, first compiling the code, training all the components, and then running the full pipeline with assessment. This was done using Jenkins and a dedicated compute farm that was running actually 24/7 for the duration of the project, and that was for many years. As the features became more complex and more and with more semantically rich, the data that they needed, like knowledge graphs or co-occurrence of words within sentences, grew to tens and even hundreds of gigabytes, and that no longer could fit on a machine. So not even server machines that we use. So we had to move to an architecture where we have also supporting services. These were on dedicated machines that used a lot of in-memory caching to be able to respond to the clients. And the issue is this: it takes too long to load, like 10 gigabytes of data per client code. But once you move it to the server, you start to have issues with latency. So you have to really play it and what's the granularity of the services in order to achieve good latency and also good throughput. And what this comes to is a recurring theme that we'll see also in the rest of the presentation. As NLP researchers and machine learning researchers work, they need to have some knowledge of the architecture. Otherwise, even the day-to-day research is really hampered. So the next big thing was the next inflection point, as we said, was the data. So we used to work with Wikipedia with 40 gigabytes, and we then got a corpus of newspapers, articles, and scientific journals that grew up to 3 terabytes of data, 400 million articles. And this really had to change both methodological changes and architectural changes. In Wikipedia, there are about dozens or hundreds of relevant articles per topic, but in this corpus, it could be thousands. So the idea to retrieve articles was out of the picture. So we had to move to sentence level retrieval. And it also meant that Lucene, which worked quite well for Wikipedia, was no longer an option. So we had to move to Elasticsearch. And beyond that, the human annotation, which was done exhaustively on all the relevant articles of Wikipedia, couldn't scale anymore. We had to move to crowdsourcing platforms like you're maybe familiar with like the Amazon Mechanical Turk or Figure 8. And these employ new problems of how you interact with these systems automatically during your nightly regressions to make sure that you update your labeled data consistently. And also things like fraud and identifying malicious users. And then came the area of deep learning, where more and more aspects of the system were performed using Python frameworks of deep learning. And that includes more services. Now, these services are services that are developed by the NLP and machine learning researchers. So they had to learn these additional capabilities, and we had to integrate it all within that pipeline that we mentioned before. And so we no longer could use manual deployment of services. We had to move to Docker and Kubernetes and Jenkins to be able to auto-deploy these services. And again, the NLP researchers had to learn at least some aspect of that on their own. And as Ranit demonstrated, this was only a part of the system what we talked so far. We really have also the speech construction and the opponent speech analysis. All of these imply more services, more Java code, more Python code, all need to working together, and the nightly, or not the nightly, the continuous integration has to be running flawlessly. Finally, we had the event. The event, from our point of time, was a singular moment we could not fail. We wanted to remove or reduce as much as we can a single point of failure event. And so what we did is we approached it in a multi-tiered approach. The first approach was we're going to run everything, all that you saw before, in two separate instances. One here on the IBM Haifa premises, compute premises, and one on the IBM cloud. So if something happens to the network, to the sites, to an IBM cloud environment, we will have the backup, and we could, within the event, by a push of the button, change actually which system is actually interacting with the actual totem that was representing the debater system. In addition, there was the chance of code failure, of deterministic code failures, and that we try to approach by actually fencing different components and subcomponents. So if they fail, they will have a fallback to suboptimal behavior, but still something that would not prevent the system from completing its run. As we look forward, even at the later stages before the event, we actually look back and saw where are we going to go with this technology. And the idea from the start was really not only to show the debater and what AI can do, but also to find ways to improve human decision making. So what we are doing right now, and it started last year, is really taking the entire debater system, making it into separate components, purely microarchitectural, microservice architecture, deploying it on the IBM cloud in a way that allows us to build application over it. One application is speech by crowd, in which we ask people to give their input on some controversial topic. This input is automatically analyzed and creates a narrative both pro the topic and con the topic. We had 2 demos in CES and Think in the US earlier this year, and we have the first live instance of this event next week in Tel Aviv, in Think event Tel Aviv. And as we say, we are going to continue this direction of providing services, providing this as a platform for enabling debate-related or argumentative use cases. So finally, I will conclude with the recurring challenge that we saw. So one thing is the full integration. It's not enough to check each component as separately. We have to have complete integration throughout the life of the project and all the challenges that it faces. There's the issue of large data. Dalit said it, right? Getting the data is one thing. Being able to use it and effectively using it is a different point. The third, probably common to many systems, how to make it resilient when there are so many different components that have to work together. And finally, it's really it's even more than that. How do software engineers and machine learning and researchers and NLP researchers work together effectively in a world that you cannot simply separate these two concerns? And I think this is a challenge that we'll continue to face in the future. So, thank you very much. one point about the team. This was actually something that's a worldwide effort, but focused primarily in Tel Aviv and in Haifa. So we're very proud that this is an Israeli project, and I want to thank everyone who worked on that.